Welcome to the second part of Algebra 2. We're going to go through example 4 and 5 today. Let me go ahead and grab that, delete, zoom in here. And there we are. Okay, so example number 4. These guys are a little bit easier than the previous 3 examples. I think I said that yesterday. So this function capital Y, and it has this subtext minute, of t represents the number of people in a crowd who yawn. So if I yawn right now, does it make anyone else yawn? Apparently, there's interesting studies that link yawning and if you are affected, if someone else yawns, do you yawn as well? It usually indicates how empathetic you are, how well you understand other people's emotions. Anyway, this function of yawning is 3 times 1.02 to the power of t people. Every hour, the number of people who yawn increases by what factor? And normally we just say, oh, factor 1.02, we're done. 1.02, except no, we're not done, because check out the unit difference. I put it in bold. It needs to be in units of hours. It is right now in minutes, not hours. It says minutes as well here. It's like everywhere, right? So how do I convert from minutes to hours? And it's kind of the same principle from the previous examples, except it's always the same thing over and over. It's very procedural. So you might already have an idea. And for some reason, I can't see people's cameras. I don't know why. Like, you guys have your cameras on, but on my screen, they went away again. I don't know why. If I turn those on, no, I don't know why that's not showing up. Weird. But let me go ahead and show the first example, and then you guys can probably all do example 5 on your own. So the first thing that I should point out is hours versus minutes. Guess what? Hours are bigger than minutes in the amount of time that you have. Minutes. Because an hour is 60 minutes. So, and what is the thing that we want? We want hours. We have minutes. This is the thing that we want. It feels silly for me to write out this diagram, but believe me, it does help if you think about it like this. Okay, I want hours, and hours is bigger than minutes. That's the first step, which means I need to raise to a power of however many minutes are in an hour, versus taking it to the power of 1 divided by that number. So we know that there's 60 minutes per hour. So I'm either going to do 1.02 to the power of 60, or I'm going to do 1.02 to the power of 1 over 60. It's always 100% of the time, as long as you know that there's 60 hours a minute, one of these 2 answers. And you need to be thinking, does this number need to get bigger, or does this number need to get smaller? This number needs to get bigger, so I'm going to take it to the power of 60. If I take it to the power of 1 over 60, it will get smaller. In fact, it will go basically down to 1. So let me pull up my calculator to do this problem. What was my number? 1.02, 1.02 to the power of 60, and that is 3.281. So this is 3.281, and you can see if you did to the power of 1 over 60, 1.02 to the power of fraction 1 over 60, it basically turns into 1. So this is basically 1.000. Which of these numbers gets bigger? This one gets bigger, and we want it bigger. So the answer here is 3.281. 3.281. It didn't say what to round to, so I just chose a random number. So the reason that this works is you're basically saying there are 60 minutes per hour. So this is really saying 1.02 to the power of 60t. And if you remember, in order to get this thing back to 1, I need to plug in 60, or I need to plug in 1 over 60t, or I need to plug 1 over 60 into t. Man, I cannot talk today. If you plug 1 over 60 into t, then our ratio is still 1.02. If I want to absorb this 60 into the 1.02, now this is basically saying every 60 minutes, because 60 is now in the denominator of the fraction, which is kind of how I introduced this all the way back in 7-1. So if I've totally confused you by talking too much, this is how I can simplify as much as possible. Take your scale factor, and it's going to be either to the power of that ratio or 1 over that, depending if you want to get bigger or smaller. All right, so now is a good time to ask questions. And I can't see your cameras, so you're gonna have to like use the raise the hand feature, or I can just go like this. Are there questions? Now I can see you guys. Okay, well, with that then, what I want everyone to do is I want you guys to work on example number 5. It's basically the same thing, except you're not going to do the power of 60 or 1 over 60. It's different because I'm converting between years and months. So everyone give example 5 a try. I'll make sure that example 4 and 5 are on screen so you can compare and contrast the two. Good luck. How many people have an answer by show of hands? And now I can see your cameras. I have no idea why just turning it off and on again works, but it is like the magical thing. Okay, so I see Sergio, I see Wyatt, I see Fernando, I see Charles, maybe he's scratching his lip, I don't know. How many people have an answer to example number 5? Only those 3. Okay, let's hear from Sergio. How'd you do example 5?
So since the factor is 3.2, you put like 3.2 and the square root of 1 over 12.
Or to the power of, yeah, power of 1 over 12.
And that's 12 because there's 12 months in a year. So then you put 10 decimals and you get 1.1017.
So this is equal to 1.1017, 1.1017. Cool. You guys agree with Sergio's answer? Thumbs up, thumbs down. They're busy doing their homework. Charles says yes. I also say yes. Good job. Please ask me questions about example 4 or example 5. Otherwise, I'm going to jump into reviewing older homework. All right.